Lab number 1, measurement, length and mass. Introduction. In the first part of this course, we will be talking a lot about how scientists make observations of the world around them. Remember, though, that scientists are not only interested in what they observe, they also are interested in providing explanations for how, why, and when the things they are observing have taken place. One of the things that scientists do to help them answer these kinds of questions is to make more careful kinds of observations than you or I would normally make. Quite often, rather than just using their senses to make observations, scientists use extensions of their senses that we call instruments. One of the main reasons that scientists have for using instruments is to make measurements. Remember that a measurement is just a special kind of observation. It is a way that scientists have of quantifying, meaning giving numbers or amounts to, their observations. In this lab, you are going to get some practice making measurements using the measurement system that is used by all scientists worldwide, the metric system. Measuring length. 1. Note that your metric ruler has a scale composed of evenly spaced lines that marked off the ruler into equal parts. On the scale in the figure, the longest numbered line is equal to a length of 1 centimeter. That is, the space from one numbered line to the next numbered line is equal to the length of 1 centimeter. The first part of this word, centi, means 1/100th. The second part of this word, meter, is the standard unit of length in the metric system of measurement. A meter is made of 100 centimeters. Note that each labeled centimeter is further broken down into unlabeled millimeter units. 2. When measuring, do not use the actual end of the stick. It is often worn away or has a metal tip that would make it inaccurate for measurement. Start your measuring on either 1 or 10 and then subtract that number to find your measurement. Or use a math ruler that has the 0 marked off away from the end of the stick. 3. When measuring in centimeters, always measure to the nearest tenth of a centimeter. Example, instead of 5 centimeters, you would write 5.0 centimeters. 4. All measurements have two parts, number and label, no naked numbers. Example, instead of 10.3, you would write 10.3 centimeters. Things to remember. Make all measurements in centimeters. Record all measurements to the tenths place. Label all measurements with the correct units. Write all your answers on the answer sheet provided. Procedure for measuring length. Each group of 2 people should obtain a metric stick and a metric ruler. Measure the rectangular solid in Figure 1. Put answers on the answer sheet. Question number 1. How long is this drawing of a rectangular solid? Question 2. How wide is this drawing of a rectangular solid? Question 3. How high is this drawing of a rectangular solid? Measure your lab table next. Put answers on the answer sheet. Question number 4. How long is your lab table? The longest measurement of the top of the table. Include units. Question 5. How high is the top of your lab table from the floor? Include units. Next, measure the length of the following objects. Record the measurement and unit. Question 6. What is the length of a drawer in the cabinets on the side of the room? Question 7. What is the length of one side of a floor tile? Next, we will be measuring mass. Measuring weight is an important part of life. Dieters often want to know if they have gained or lost weight. Produce in a supermarket is weighed before it is purchased. In science, it is important to be able to weigh objects, but scientists actually measure mass rather than weight. 2. Weight is a measure of how gravity pulls on an object. An astronaut on the moon will weigh less than on Earth because the moon has less gravity than the Earth. Mass, on the other hand, is a measure of the amount of matter or material making up an object. Therefore, an astronaut would have the same mass on either the moon or the Earth because he or she is always made up of the same amount of material. Since mass does not change from place to place, scientists usually measure mass rather than weight. 3. You will be using an electronic balance to measure mass. The standard unit of mass in the metric system is the kilogram, or 1,000 grams. A gram is 1,000th of a kilogram. The metric symbol for gram is G. The electronic balance will measure in grams. 4. Before using the balance, make sure the balance is zeroed. Procedure for measuring mass. 1. You and your lab partner will each receive a cup containing 2 objects, a total of 2 cups per group. You may need to share cups with another group. Be sure to record the cup numbers. 2. Each partner should find the mass of his or her objects and record the answer on the table on the answer sheet. 3. All measurements in the lab are to be made to the nearest tenth of a gram. 4. All measurements are to be labeled with the correct units. Example, 20.3 grams. Questions. Write the answers to these questions on the answer sheet provided. Include units. Question number 1. How many centimeters are in a meter? Question number 2. How many millimeters are in a centimeter? Question 3. How many millimeters are in a meter? Question number 4. The ruler below is a broken section of a metric ruler. However, the part of the scale that remains can still be used to measure the length of the object above it. What is the length of the object to the nearest tenth of a centimeter? To answer question number 4, look at the picture below it. For questions 5 through 8, the drawings below are parts of a metric ruler. The numbered lines are centimeters. Each centimeter is divided into 10 millimeters. Record the measurement that each arrow points to as if your measurement started at 0. Record each answer to the nearest tenth of a centimeter. For questions 5 through 8, use the following 4 pictures below. Then, once you have done that, convert your answers from questions 5 through 8 into millimeters. Using the same 4 pictures, answer questions 9 through 12. Questions 9 through 12 are a conversion of the measurements you made for questions 5 through 8. Question 13. NASA determines the mass of a piece of equipment used by an astronaut to be 3,300 grams on the Earth. How would the mass of this equipment on the Earth compare to its mass when it is on the Moon? The choices are the mass would increase, the mass would decrease, or the mass would remain the same on the Moon. Select one answer. Question 14. How would the weight of this equipment on the Earth compare with its weight on the Moon? Your choices are the weight would increase, the weight would decrease, or the weight would remain the same on the Moon. Select only one answer. Question number 15. The Moon has less gravity than the Earth because it is smaller than the Earth. If the strength of gravity increases as the planet gets larger, how would you expect the weight of this equipment to change on a planet that is larger than the Earth? Your choices are the weight would increase, the weight would decrease, or the weight would remain the same on the larger planet. Select only one answer. Conclusion. In one or more complete sentences, explain why it is important to put a unit after each measurement that you record.